Hey guys, it's Miss Marfleck here. We're continuing with our next video on trigonometry. Now the last time we met, we went over our two special right triangles, our 45, 45, 90, and our 30, 60, 90. We also went over SOHCAHTOA, our sine, cosine, and tangent, and now we're moving on to angles. Now this is a really important lesson because we're going to go over a lot of vocabulary. And if you write down these definitions and just highlight them or box them in, then when you're doing your homework, 4 or 5 lessons from now, and you see a word like coterminal, quadrantal, standard position, reference angle, you could always go back to your notes and remember, oh, I wrote that down in my angles lesson, and that will kind of help you complete the problem. If you don't know these definitions, trigonometry is going to be very difficult since it is relating angles with the side lengths of a triangle. So we're going to jump right in, and we're first going to start off with defining the standard position of an angle. Now, when we draw angles or when you drew them in geometry, we always draw them in standard position. And standard position means that your vertex of the angle is going to be placed at the origin, which is 0, 0. And then we just have one more characteristic. It's going to be placed on the origin, and then that initial side of your angle always has to lie on the positive x-axis. And then right away, there's our first definition for standard position. I'm going to use my cute orange highlighter here. And there's my first definition. All right, we're going to jump right into some practice problems with our standard position. And here's the first one. And our directions are going to be to draw in standard position. Now we're going to do both positive and negative angles. We're going to first start off with the positive, and I'll show us a little drawing for that. And here's the first one. We want to draw 235. All right, so I want you to draw 235. All right, now the first one we do, we're going to draw really detailed because I want to show you the axis. Here's our regular XY coordinate plane. We open up with angles that are positive. We open up counterclockwise. So I'm going to put a positive theta here looking at that arrow. And then negative angles, we open up downwards. And there's my negative theta, and then we have that clockwise rotation. You can remember, hopefully, that this is quadrant 1, this is 2, this is 3, this is 4. So I start with my vertex at the origin. I have my initial side, okay? Maybe I'll label that for us as well. This is your initial, and then when you open up and rotate, once you finish rotating, that's called your terminal side. So we're going to open up with our initial side here, and we're going to pass 90 degrees, which is a right angle. We're going to pass 180 degrees, which is a flat line. Then we add 90. This axis is 270, and this is 360. So 235 would be between here and quadrant 3. So we draw that arrow, and we open up, and just a rough estimation in quadrant 3. Now, not all of the problems are going to be this detailed, but I do want to show you the 90, 180, 270, 360, the quadrants, and what I'm really looking for is initial and terminal side with that little rotation there. All right, so we just drew 235 in standard position. Now we're going to take a look at number 2, and we're going to draw 315 degrees in standard position. So I'm going to start off here, and I'm going to label my 90, 180, 270, and 360. It's really important to know these 4 degrees here, and because you can't draw the angle without knowing these 4 degrees. We start at the origin, we open up counterclockwise with our positive angle, and here we are lying in quadrant 4. And then if you'd like, some people do right here, that this, angle here is 315 if you'd like. Okay, just opening, showing that line is showing the 315. All right, moving on, we're just going to do one more together, and that's going to be negative 120 degrees. Now we can see, from my little pictures here that now the negative angle opens downwards to quadrant 4. And we're going to label first. This is now negative 90 degrees because we're opening up downwards. This is negative 180 degrees. This is negative 270 degrees. And this is negative 360 degrees. We start at our vertex at the origin, our initial side, and we open up, and my terminal side is going to be right there in quadrant 3. And then I could put here that this is negative 120 degrees. All right, so that's it for our drawing angles in standard position. And now we're going to move on, and we're going to have another definition here. And our next definition is going to be a quadrantal angle. Now, we have 4 quadrants, and we drew angles in standard position that landed in a quadrant. All right, but quadrantal angles are actually, I think, a little funny that they have the name quadrants because they don't actually land in a quadrant. Instead, their terminal side, which is the side that we open up and rotate, will always lie on an X or Y axis. So, you know, some examples here. First, highlighting that this is yet another definition. We're only 6 minutes into the video and we got 2 definitions already. You know, I could put here, draw the quadrantal angle. So just doing some work with the definition here, acknowledging that all of the angles that I'm listing here are quadrantal angles. And we're going to take a look at this very first one, and that one's going to be 90 degrees. So when I open up here, I'm going to see that my terminal side lies on the y-axis. So 90 degrees is a quadrantal angle. All right, another quadrantal angle would be 270 degrees. When I open and I rotate, I don't land in a quadrant, okay, but instead I land right on that y-axis again, and that's 270 degrees. And then I'm just going to do one more for us, a negative. Here it is, 3. We'll have negative 180 degrees. All right, so any angle that opens up and its terminal side ends up lying on an X or Y axis, we're going to see that those are called quadrantal angles. Now, when we're working with the trigonometry, we have certain rules or you know, triangles that we use when we're finding sine and cosine of maybe angles like this. And then we have a whole new different set of rules when we're finding sine and cosine of quadrantal angles. All right, so once again, make sure you have down those 2 definitions. I'll put them both here highlighted in orange. Make sure you have down standard position and you have down quadrantal angles. All right, now we're moving on, and our next definition is going to be called coterminal angles. All right, I told you at the beginning of the video, a lot of vocabulary here. All right, coterminal angles can be a little confusing at first, but then once you know the rule on how to solve for them, I think they're quite easy. And our definition here is that terminal angles share the same exact initial and terminal side. Now, that may seem like they are the same angle, but they're not, because what we're going to see is that they're on different rotations. All right, so they share the same initial and terminal sides, but on different rotations. And then I'm going to highlight this again for us because this is a very important definition, and you might be asked to find a coterminal angle, you know, a few lessons from now. If you noticed at the beginning of our notes, I put angles here, degrees. And my Algebra 2 Honors class, we're going to be doing things in radians, so we're going to do everything all over again with a new measurement of angle, so you really need to know these definitions. All right, so coterminal angles share the same initial and terminal side, and then we solve for them by doing a simple algebraic calculation, solve for coterminal angles, we can add or subtract 360 degrees. Now we can do this as many times as we want. Sometimes you have to take a look at the directions and see what you're looking for. And we're going to see in this first set of directions, our goal is going to be to find one positive and 1 negative. Now that may not always be the case. I could ask you for 2 positive coterminal angles. I could ask you for 2 negatives. I could ask you for just a negative, or so on. Find 1 positive and 1 negative coterminal angle. And that's going to be for each problem here. We're going to restart the numbering because we're kind of under a new topic. And here we are, number 1. Our angle is 420 degrees. All right, so our goal is to find a coterminal angle. So I'm looking for the same angle that shares the same initial and terminal side. And I can really quickly, actually, maybe I'll draw 420 for us. And here we are. We open up. We pass 360. And then if you kind of count on your fingers, we're 60 degrees past 360. So I can start with my 420, and then I can use my algebraic equation here, and I can subtract the 360 to first get me a positive coterminal angle. All right, and then when I subtract here, I'm going to get 60 degrees, and there's my first positive. All right, and then now I want to find a negative coterminal angle, so I'm going to start at that 60 degrees, and I'm going to subtract another 360 degrees, and we're going to see we're going to have a negative coterminal angle at negative 300 degrees. And then if I want to draw these two, you'll see that 60 degrees is right here, and you'll see negative 300 degrees, I open up downwards, and I'm landing here in quadrant 1. Now you don't need to draw the pictures because I didn't ask you to draw it in standard position. I just asked you to find 1 positive, 1 negative. So your answer here is 60 degrees and negative 300 degrees. But I want to draw the pictures so that you can see that they are the exact same angle, they're just on different rotations. All right, now we're moving on. We're going to take a look at number 2. And directions are still the same. Find 1 positive and 1 negative. And then I will draw this one for us again. Here's negative 120 degrees. We open up downwards because it's negative. And there's our angle in quadrant 3. All right, so I'm starting at negative 120 degrees, and I'm just going to find the positive one first. So I need to get into the positives between 0 and 360, which means I need to add a full rotation, which is 360 degrees. And then that's going to give me the angle 240 degrees. And if I went to go draw 240 degrees, I'd pass 180, and we're going to see that is going to be the same angle, just a different rotation, shares the same initial and terminal side. All right, and then now I want to find 1 negative because this is my positive, so I want a negative. So I'm going to start again at my 120, and I need another negative, so I'm going to subtract another 360, and that's going to give me negative 480. Now you can use a calculator. When you get to pre-calc, you will not be using a calculator. And then I could draw this one also for us. We open up downwards because it's a negative angle. I pass negative 360, and then here I am at negative 480, and we're going to see that it is the exact same angle. All right, here's number 3, almost done with coterminal angles. And we're going to have 225. And then I'll draw 225 for us. Just like the negative 120, it is in quadrant 3. All right, so these are rough sketches. They're really rough. And I'm finding a positive and a negative, so I'm going to go ahead and find that positive one first, which means I have to add 360. And then I do 225 plus 360, I get 5, 8, 5, I get 585 degrees. And then if I wanted to draw that, here I am. I'd open up, I'd pass 360, and then I can add another 180 to 540, and then another 45 degrees. And we're going to see it's in the exact same place, quadrant 3. All right, and then now I'm starting with my original angle, and I want a negative coterminal angle, which means I have to subtract 360 degrees. And then when I do that 225 minus 360 degrees, I get negative 135. Which means that I start at my positive x-axis and I open up downwards, and I haven't quite yet reached negative 180. All right, now they may look simple because I'm just adding 360 and subtracting 360, but you really need to know the definition of a coterminal angle because I could ask you for something different. Let's say I asked you, we'll just do one example like this just to illustrate the fact that the directions can be anything about coterminal angles. So I can ask you, to find a coterminal between 0 and 360 degrees. So now I'm not asking you for a positive or a negative. I'm asking you for a coterminal between 0 and 360 degrees, and we'll do a really big angle, 1260. All right, so I'm starting at 1260, and I want an angle between 0 and 360, so I have to subtract 360. All right, so I'm subtracting a rotation from this coterminal angle, and we're going to get 900. And then I'm still not between 0 and 360, so I'm going to subtract another 360. I get 0, you know, I borrow, and then we get 540. I'm still not between 360, so I take 540, and I subtract another 360, and then this will, you know, do it for us. 0, 4, 14, we got 8 here, and a 1. All right, and then I can see that my coterminal between 0 and 360 is 180 degrees. So you can't really just memorize the steps here. I really want you to know the definitions and know that you can solve for any coterminals by just adding and subtracting 360. But then you also got to keep in mind, what am I looking for? Well, I'm looking for a positive, negative here, positive, negative, and then now the directions have switched. I'm looking for just a positive between 0 and 360. I could ask you for a positive between, you know, 2 and 3,000 degrees, 2,000 and 3,000 degrees, or something crazy like that. All right, that's it for coterminal angles. Once again, I don't mean to be annoying, but really have this definition written down. Okay, what are we moving on to now? I think this is our last definition for our angles. Yes, it is. And we're going to be talking about reference angles. All right, now everything you're seeing in this video, we're definitely going to be doing again in the future. We're going to be seeing it all throughout this trigonometry, and we're going to also be doing it in radians, not just degrees. All right. Reference angles are really helpful in trigonometry, and by definition, they are acute angles, which means that they're between 0 and 90 degrees. They're always positive, so I can't, like the coterminal, I could have a negative coterminal, or I could draw a negative angle in standard position or any other definition we worked with, but I can't have a negative reference angle. By definition, it's always positive. And then our last kind of piece of information here is that it is an angle formed with the x-axis. And I cannot stress this enough, because so many times my Algebra 2 students, even my pre-calc students, give me a reference angle that's formed with the y-axis, or they form it with a 270 angle or 90 angle, and by definition it is formed with the x-axis. All right, our directions here are going to be find the reference angle. And we're going to start off with this first one here. And I'll switch to a different color. We'll do the dark pink. And what's our angle? 150 degrees. All right, now you don't have to draw the angle, but I do think it's really helpful if you draw the angle. So I'm going to start off here by drawing 150 degrees. And we open up, we pass 90, and we're almost at 180. So that's 150 degrees, right? Vertex, initial, and terminal side. So now I'm looking for an acute angle that's positive and formed with the x-axis. So what I have to ask myself is, how far away is this 180 to the nearest x-axis? Okay, well, my nearest x-axis is here, and that's 180 degrees, and the distance away is 30 degrees. And that's my answer here. That's my reference angle, 30 degrees. So once again, it's formed with the x-axis, and you're looking at the distance to the nearest x-axis. It's always acute, so it's less than 90, and it's always positive. 30 is positive. Now, I know we don't know this yet, but these reference angles are going to be super helpful, because we're going to be able to find sine, cosine, and tangent of 30 degrees using our triangle. And what we're going to see is that sine, cosine, tangent of 30 degrees is a very similar, almost exact answer as sine, cosine, tangent of 150 degrees. The only difference is that one is positive and one may be negative, but they are the same number. So that's what we're going to use reference angles for in the future, but don't be apprehensive about that, because right now we're just solving for them. And we're going to move on. We're going to solve for another one, and that's going to be 240 degrees. And I'm going to draw this one for us again. I open up positive counterclockwise. I pass 90, 180, and I'm not quite yet at 270. All right, now you may be really tempted to say, okay, you know, in this last one, we formed it, here we're going to form our triangle here. Oh, I'll connect it here, but no, it is formed with the x-axis. So I'm looking for that reference angle and I'm asking myself, well, how far away is 240 to the nearest x-axis? And it is 60 degrees away from the nearest x-axis, because this x-axis here is 180 degrees. All right, and you can see the distance between 240 and 180 degrees is 60 degrees. All right, we'll do one more before I show you a little bit of a different method, and that's going to be here 3. And I'm going to ask you to find the reference angle for 100 degrees. And I'm going to open up. I'm going to pass 90 degrees, and here is my angle at 180 degrees. And what we're going to do here is we're going to drop down, and we're going to be forming our triangle and finding sine and cosine and tangent of 100 degrees. But we just have to ask ourselves, how far away is 100 degrees to the nearest x-axis? And here the nearest x-axis is going to be that 180 again, and it is 80 degrees away. Now, just because I noticed that the last 3 examples that I just made up off the top of my head were with 180, I lied. Miss Marflex is going to show you one more before we do one more piece of notes, and that's going to be, let's see, we'll do 315. All right, so I'm going to draw 315 now just so that we can see it. And we're going to pass 90, pass 180, pass 270, and we're almost at 360. And we're going to be using this triangle in the future, so Miss Marflex is going to put it here. And then now I'm asking, okay, well, how far away is 315 to the nearest x-axis? Nearest x-axis is here, that's 360 degrees, and 315 and 360 are 45 degrees away. All right, and it's an acute positive angle. Now, some people maybe don't like thinking the way that I think. I like to think, what's the distance from the nearest x-axis? Some people like using formulas. So if you're one of those people that like using formulas, you can use this little chart here. And we're going to use theta as our regular angle, and we're going to use our reference angle to be theta prime. So whenever we're in quadrant 1, our regular angle and our reference angle are going to be equal. Whenever in quadrant 2, to find our reference angle, we're going to do 180 and we're going to subtract our original angle, and that will give us our reference angle. In quadrant 3, we start with our original, we subtract 180 and we get the reference angle. And then in quadrant 4, we take 360 and we subtract the original angle and we get the reference angle. So kind of using this piece of information and maybe just going back and showing a different method, you know, here's 150 in quadrant 2, so I'm following this rule. So I do 180 minus 150 and I get 30 is my reference angle. Here's 240 in quadrant 3, so I'd follow this rule here. Okay, well, my reference angle is my original angle. 240 minus 180 is 60 degrees. That's my reference angle. Here, number 3, I'm in quadrant 2, 100 degrees. So I'm following the rule in quadrant 2 here. 180 minus 100 degrees is 80 degrees. And then the last one, I'm in quadrant 4 here, which means I do 360 minus 315 equals 45 degrees. So I like to think, what is the distance from the nearest x-axis? You could also use this pretty chart here to help you solve. All right, we're going to do just one more together because I think I did every quadrant except quadrant 1, and we're looking for that reference angle, and we can use the rule from the little chart that the original angle and the reference angle are equal, or we can draw a pretty picture here and see that 30 degrees is 30 degrees away from the nearest x-axis. All right, we went through a lot in this video, and these topics are really important for a good foundation of trigonometry. So once again, we went over standard position, which you should have highlighted somewhere. We went over quadrantal angles, which you should have highlighted somewhere. We went over coterminal angles, which you should have highlighted somewhere. We went over reference angles, which you should have highlighted somewhere. Okay, make sure you have all these notes down and get started on your homework, and then ask me any questions through email.